First I'll show how the strategic and tactical freight simulator fit into the Harmony MS architecture, and then I'll explain in a bit more detail the inner workings of both simulators. I'll show one of the scenarios that we worked out for Rotterdam, and then I'll also give a short demonstration in the Harmony MS dashboard. So within the Harmony MS architecture, at the strategic level, the strategic freight simulator consists of the spatial interaction freight module, or SIF, and the firm synthesizer, or FS, which respectively create a commodity matrix of tons between large zones and a population of individual firms. And these outputs of the strategic simulator are both fed into the tactical freight simulator. So here you see the both simulators. Basically, the two model components in here are the SFS, the strategic freight simulator, and the TFS, the tactical freight simulator. And the tactical freight simulator itself actually consists of a lot of different submodules, which I will briefly explain now. So the strategic freight simulator provides the commodity matrix and the firm population, which are used by the shipment module and parcel demand module of the tactical freight simulator. And these can create individual shipments for freight transport and parcels for the e-commerce segment. And then in the scheduling and parcel scheduling module, we create round tours to deliver these shipments and parcels. And besides that, we also have a gravity modeling-based module for service and construction plans to complete the picture of it. And these trips and tours can be fed into the operational freight simulator. And also within the tactical freight simulator, there's an indicator module which creates an Excel sheet with KPI tables. And besides that, at the tactical level, we also have a network module which calculates traffic intensities and emissions at the level of the road network. So for the Rotterdam implementation, we have developed this zero emission zone scenario in which we implement a zero emission zone for 6 different cities in the province of Zuid-Holland in the Netherlands. And the big one you see in the middle is the one from Rotterdam. We're actually going to implement this zero emission zone in their cities in the upcoming years. And in this scenario, we assume two types of reactions to these zero emission zones. First of all, the trips going to or from the zero emission zone can switch to using a hybrid engine. So they will switch at the edge of the zero emission zone to the clean combustion type. And the other type of behavioral reaction is a transfer at one of these red dots, an urban consolidation center, from which trips will be consolidated for last mile delivery with clean vehicles in the zero emission zone. So now let's go to the Harmony MS to see how we can run these scenarios with the two freight simulators. So here we're at the homepage of the Harmony MS again. And for the sake of time, I already uploaded the different components and templates, and I ran a few scenarios. So here we have the two components again, the tactical and the freight, the tactical and the strategic simulator. If we look here at, for example, the tactical freight simulator, you see all the input arguments that it expects and the output files that it will create. So, for example, here you have an argument which says which of these submodules of the tactical freight simulators need to be run. By default, this is all of them. And for example, there are also some input scenarios that are related specifically to the zero emission scenario. And then we have a template in which both the strategic freight simulator and then the tactical freight simulator are run. So here we have two tasks that are calculated consecutively. And here, as Francesco also just showed, you can see this visual representation of the two components. And what you'll see here is that the strategic trade simulator has these two outputs that are the firms and the commodity matrix, which are then later on fed into the technical trade simulator as input arguments. Then, as a project, we have the implementation for Rotterdam with all the input files added to it. And for this project, I have completed 3 different runs. First of all, the default scenario with all the default settings. Then I also ran a scenario with increased demand for parcels in the business-to-business segment. And finally, there's also the zero emission scenario that I ran. So let's first look at the default scenario by itself. So here we are in the dashboard tab again of the MS. And it will by default show a few of the first KPIs. So here we have a table that shows the distribution of the different shipment sizes that came out of the technical freight simulator. And what you can see here, for example, is that most of the shipments that are created are in this lowest segment of smaller than 3 tons. What's nice is that you can, besides these KPIs that are generated, if you like, you can also just download the raw output files of the simulators themselves if you do like very specific analysis. So here the technical freight simulator, for example, also provides a sheet with a lot of different tables. So if you like, you can just download these and enter them in whatever program you like. Have a look at those. Then now let's go have a look at a comparison between 2 scenarios. So first I'll compare the default scenario with the scenario in which I increased the demand for parcels. So here we have one parameter that is a factor for the number of parcels that each firm on average orders, and I increased it in this scenario. And that is something that we can see come back in this KPI table, for example. Here we see that in total the number of shipments in the parcel delivery segment has increased quite a bit, 142 to 306. And in some of the other segments, there's very small changes too, but this is more the stochasticity of this model. Then another comparison we want to show is to compare the default scenario with the zero emission scenario. So let's look at the CO2 emissions that are created by the technical network module from the freight simulator. So we can add this both as a table. So here we see by municipality how much emissions are emitted in total and also for the parcel segment. But what's nicer to look at is also the bar chart visualization that is created. Yeah, here it is. So here you see in blue the default scenario, the CO2 emissions for the municipality, and in red the CO2 emissions in the zero emission scenario. What you see here, for example, is a small decrease in emissions in gemeente Rotterdam and in gemeente Den Haag, and that's because in a part of these cities, the zero emission zone is implemented, so there are clean vehicles driven in part of the city. And actually, these increases are relatively small, not only because it's a part of the city, but also because in the zero emission scenario, quite a lot of rerouting has to be done. So a trip that normally would drive through Den Haag, for example, with a regular fuel engine, might have to make a big detour around the city now to avoid the zero emission zone. That can actually, in the surrounding municipalities, also create an increase in city emissions. So that's a useful finding in this scenario also for the policymakers that have to really take into account this detour effect when you implement these zero emission zones. This is basically what I wanted to show about how I apply the trade simulators in the Harmony room. So let me know if there's any questions.